So I serve as the coordinator of one of the platforms, one of the docking stations. I like that a lot, of CGIAR, the big data platform. And I like to say that the goal or the mission of Big Data Platform is to mobilize CGIAR data particularly and use it in new and exciting ways for food security. The other way I like to describe the platform is to say that we need to build tighter linkages between the data that we are generating and the kinds of impacts that we seek to have. So Elizabeth asked me to put together a sort of bigger picture or framing presentation for today. And I gave it some thought, and I thought really like if we were to try to figure out what the larger framing is across all of our different types of work. And so how do you frame this question about, what it is we're all engaged in? And so I started thinking a lot about the interplay and the interaction between formal types of knowledge that we structure and we organize and we store and the supporting data and the data products, and the interaction with the wider, less organized, less structured world. It's really the interaction between the how do we actually, generate these data products, and then how do we actually interact with the wider, increasingly more digitized world with those data products? And so I'm going to spin through several different kind of aspects or facets of that general theme. The first which I was looking into a collection of essays on the new data-driven scientific paradigm from a little over 10 years ago, and this text really jumped out at me about the 21st century. In the 21st century, the vast volume of scientific data captured by new instruments on a 24/7 basis, along with information generated in computer models, is likely to reside forever in a live, publicly accessible, curated state for the purposes of continued analysis. And so, I think within the context of CGIAR, we are a long way away from realizing that vision. And I think that even our sector, public, private, and nonprofit, many actors are still struggling to realize this vision. And so we need to understand and unpack a little bit more what are some of the barriers to getting there. Within the context of CGIAR, I think it's fair to say that there are very different research and scientific focus points or priorities that inform our scientific infrastructure. Very different budgets, skills, IT capabilities, and the different organizations different institutes comprising our organization. Different regulatory and policy environments that our centers and even our regional offices within our centers must navigate and abide by. And this seductive idea that we can manage all of the complexity that loads on our design tasks to sort of do systems that actually help us to move towards that vision. It gets very complex, and the more complexity you take on, the higher chances are that you will actually not achieve building a functional system for everybody. And so this kind of definitive platform challenge. And so I think really what this means is that we're forced to look at kind of investments on the kind of, broad utility types of investments that help move our sector forward, but don't presume to design absolutely everything for everybody. And at the same time, of course, we do have particular capabilities that we invest in. And so, targeted investments in systems that help us to do something important for our work. And so, our next stop on this discussion about the interaction between formal and informal models or approaches is I want to use 3 examples where there are, good evidence behind and really great examples of digital interventions in farming systems where there has been an impact or a value add through use of digital technologies. And so the first of which is based on a technology called interactive voice response. And for those of you who may not have worked with it, interactive voice response, or IVR, is like the technology. If you were to call your bank and a voice comes on the phone and it says, for English, press 1, for French, it would say it in French, I'm sure, press 2, and so on and so on. So there are services all over the world using IVR to deliver agricultural advice. And there's a particular example that I like. There was a randomized control trial done by Harvard University of one of these services. And they found some good impacts in terms of adoption of recommended practices, some good crop outcomes that they were able to trace related to the adoption of those practices. But the really interesting thing about this example is that they did the exercise of evaluating customer willingness to pay and the value of the advice that was given. And so as you could imagine, some very rural, very poor farmers were not particularly interested in paying very much for this service. However, the indication that there's value in those advice indicates that somebody could come in and capture that value. And so that could be a cooperative or a contract farming operation or what have you. Another example that I like a lot is there's some advisory services rolled in, but also a financial product built on an existing consumer and farmer behavior, specifically geared towards access to inputs. And so the existing behavior or the customer behavior was, you go down to the corner store and you buy a little scratch card and you input the code and you get some minutes to speak on your mobile phone. In this case, you could go down to the store, buy a scratch card, and you're saving towards buying inputs the next planting season. And so MyAgro took it on themselves to then get you the good quality inputs and the good quality advice to go along with them. And as you would expect, those who did not have access to good quality inputs and good quality advice had significantly poorer crop outcomes than those who targeted. And then lastly, an example from the International Center for Tropical Agriculture, where I am based. And this is like one of the kind of few true sort of big data feeling methodologies and approaches where the Rice Growers Federation of Colombia reached out to CIAT specifically to try to understand why rice yields were declining. And they mobilized a bunch of data, 40,000 crop events, as I understand, and you could pull soils data, meteorological data, and so forth. And they did a bunch of, sort of a combination of like machine learning and traditional approaches to analyzing these data, and found there was an underweighted or managed factor, which was higher nighttime temperatures. And so this resulted in a recommendation in terms of planting time and or using another readily available variety in the marketplace. And so this guidance ultimately had a tons per hectare impact. And so it's really interesting in that all of these different ways of engaging through digital media and digital interventions, you could call them, digital channel driven, where you can interact at scale with even very rural, very low income farmers. You can find new ways to make value chains, sort of the links in value chains work better together, as in the MyAgro example, or analytics driven, where researchers typically or commonly are revealing something really important about the world that then, it results in an actionable insight. And so all of these things are converging on, I think the kind of buzzword for it now is called decision agriculture, where, we look at the capabilities that, finite, distinct capabilities that come from the precision ag world, and we look at both how do we build those capabilities in developing economies, and how do we integrate them into more quality, more timely, more localized decision support. In interest of time, I won't get into the architecture dimensions of that, but it's something that we're actively working on and collaborating on. And so all of these different interventions or models, they depend on, it's changes in the digital world, changes in the digital economy, The increasing ubiquity of mobile phones, the increased access to imagery to be able to do geospatial analyses, the increasing ubiquity and lowering costs of sensor technologies, democratization in computational power, and access to storage. All of these things are enablers that help these engagements with the digital world. And I would say that the data that we produce in a public good sort of mindset and with a public good mission are critical parts of that overall ecosystem for those kinds of interventions to really flourish. Remember early on we talked about if we're investing in systems and we're navigating all of our institutional complexities, we kind of have to do broad utility kinds of investments and really focused capability based investments. And so this is one of the kind of flagship investments of the big data platform. It's a pan-CGIAR data search and discoverability tool where you can do keyword searches and it will enable you to identify publications and data sets across 30-some open data repositories across CGIAR. Whoops. And so the developers right now are working really actively on how do they look into those data types and assets and apply semantic web to them so that increasingly you can do more and more nuanced queries and you can search, you can actually start getting results that, cross domains. And so, our hope is that this will start to map to and enable more and more systems where, the semantic web stack and systems can increasingly interact with and interoperate with other types of systems where we actually are intervening in the wider world in various ways. Now, we talked about focused capabilities, and so I think it's a suitable example for Montpellier. My understanding is that the wine industry has pretty well adopted the integration of data on soils and climate and management and so forth to get much more finer scale decision making about basically finer intelligence about their field. And so in the case of terroir, about how in the case of sorry. Do you have some water? Thanks. There are, the terroir view. So I found this, I poked around and I found this particular use case where a firm is offering this product called Terroir View, where you can actually map, where the particular floral or earthy or spicy or whatever notes that are in the resulting wine to increasingly map those back to location within a farmer's field. And so this is clearly, a developed economy example, but if we can determine, floral and spicy and earthy notes, we can certainly, working with subject matter experts, understand the environmental impacts of farming, the social dimensions of farming, economic incentives and markets, and so forth, for, when we're intervening in developing economies. Here. Much better. So we can actually start to understand and see these trade-offs. In fact, these radar graphs, there are any number of radar graphs out there where you're talking about the trade-offs of different flavors and aromas of wine. We can see the trade-offs of actual interventions in farming systems across these domains. And so this actually suggests how we go about organizing and how we go about curating and how we go about prioritizing the interoperability between types of data. If we were to build a system for sustainable farming intensification, it would probably have these elements, and we would see how would we interoperate with data across those domains, with genetic data, and we would want to make sure that we could layer in imagery and get greater intelligence about how we're going to navigate and use those data across multiple scales and across multiple time series. So this is still a lot of complexity. Early on we talked about how to navigate and manage complexity. And if we take off too much complexity, we might actually risk taking a really long time, in which case then the goals will have changed, or just not wrangling that complexity to the ground really sort of ever. And there's a great kind of design precept from a pioneering database scientist in the US named Jim Gray, and he recommended that if you're building a system of this type, you should really design around being able to ask 20 good quality queries that you can, work directly between the system designer and the subject matter experts, and you can actually kind of take on a manageable level of complexity, because if you can answer 20 good quality queries, you can probably answer many, many, many more queries. And so this is an interesting design precept as we look at this balance between bespoke targeted investments and we look at broad utility investments. And so I'm put my timer so they don't come and tackle me here. And so, we talk about the beyond the census of things. And what I mean by that is that we're at this really interesting, fascinating juncture, thanks to digital technologies, where we can actually start figuring out the interactions between our formal structured knowledge and these informal ways in the larger just, human and economic lives of people that we aim to have an influence or an impact on. And so I want to talk a little bit about what it means to sort of start to move beyond the census of things. And so, we know that machine learning approaches are very good at finding clusters of things. Sometimes we don't even know why those things are clustered. They're very good at finding relationships within those clusters. Some cases we may not fully know what relationship we're interested in from the outset, but we can, supervise that process a bit more. And if we need to, we can even find relationships between different clusters. And so, this particular capability of machine learning is really important, and it unlocks new capabilities for our work. So, for example, what we're seeing right here is a very high-resolution wealth and poverty map in Rwanda that was developed using 800 surveys and purpose-built surveys, and then informed consent with the survey respondents to get their mobile phone numbers, and then many billions of data points about who called whom from where and so forth, metadata from the mobile network. And so using these clustering approaches and so forth, they were able to generate this extremely, even kind of frighteningly high resolution map of wealth and poverty at something approaching a national scale within Rwanda. So working at these different scales, we can almost imagine a sort of multi-level chess game where each of the scales is somewhere we can organize our formal knowledge, and we examine the interoperability and the interrelations between those formal knowledge, and machine learning can help us to accelerate that process and also help us to understand the relationships between those levels in ways that we might not have anticipated before. So, this enhancing ability of, working from our formal knowledge and then using our formal knowledge to examine relationships in the wider world is something that I think we're going to continue to see and continue to unpack. This right here is a dispersal model from disease that actually, if you look in the literature, you see that the dispersal model of messages is very similar to the dispersal model of disease. I think this one was like influenza. And so as human beings are increasingly networked, we have the ability to look into and work through those networks in new and exciting ways. So this is my last example along these lines. This is the one side of a Facebook chatbot that Big Data Platform has invested in through one of our innovation processes, where specifically it's with a startup called Farm Inc. And specifically, researchers and subject matter experts from the Livestock Research Institute are tagging pictures that appear on the chatbot according to what this health problem these things appear to be. Now, this chatbot has about 30,000 farmers that are trading experiences, trading pictures, comments, building community across all 30,000 of them using Facebook, using this chatbot. And we've got this instance where a couple of subject matter experts can actually engage with that wider community and be part of that community in a sort of more horizontal way. And so one of the really interesting things about this community to me is this code switching that's happening between Swahili and English between farmers. And I don't read or speak Swahili, so I don't know what they're saying, but you can see someone here is feeling disappointed and someone here has a kind of triumphant message about having accomplished something. And so, this interaction and this bridging between a few subject matter experts who presumably also speak Swahili at ILRI, kind of becoming part of this community and engaging with these kind of informal knowledges opens up this opportunity where ontologies and taxonomies now interact with folksonomies and multiple languages and code switching and just informal ways that people are classifying and describing reality. And I think it's something that can be really potent, and we'll see how it develops over time. And so lastly, here, we're organizing, and really it's our formal knowledge that will enable us increasingly to interact with these informal knowledge. And this exercise of going through understanding the linkages among things and continuing to sort of complete the census of things will enable us to do that with greater and greater efficacy. So lastly, I just want to end with this statement that I don't fully understand. Because I'm not a Swahili speaker, but there's clearly something kind of triumphant about this, about now it's accomplished. And so I think pretty soon we'll be able to see more and more farmers saying now it's accomplished through this bridging of formal and informal knowledges and approaches through digital media. Thank you.